Shall we start now? Muthukumar sir?
Yes, sir.
Oh,
Start.
okay. We can start.
The art of being happy is to be satisfied with what you have. No medicine cures what happiness cannot. A very happy morning to all. On behalf of Karpam Institute of Technology, principal, staff, and the students, we feel immense proud in welcoming you all for our 8th International Conference on latest trends in science, engineering, and technology. I extend my warm welcome to our chief guest, Ms. Charu Verma, Senior Principal Scientist, Head IT and Digital Information Resources. 21st century is a century of science and technology. Different inventions of science have made our everyday life simple and stress-free as well. On the other hand, the economic growth of country also depends on the growth of science and technology. India never fails to prove its power in the field of research in science and technology. Our country is among the top 10 countries for scientific research. Research plays a significant role for the improvement of lives in the given society. With this note, I welcome Dr. K. Muthukumar, Professor and Head of Electrical and Electronics Engineering Department, to deliver the welcome address.
Yes. Good morning to one and all present here. On this day, the participants from various institutions to join this virtual inaugural session of 8th International Conference on Latest Trends in Science, Engineering and Technology, that is ICLTSET 2022. I welcome our beloved chief guest, Mrs. Charu Verma, Senior Principal Scientist, Head IT and Digital Information Resources Division, DIRD, Editor, Journal of Scientific and Industrial Research, JSIR, Director, Secretariat and Research Cell, Co-PA of Prabhas, CSIR NISCPR Dr. K.S. Krishnan Marg, New Delhi, for kindly accepting our invitation and delivering a keynote address to grace an inaugural function. I welcome our beloved Principal Dr. P. Manimaran and Vice Principal Dr. D. Banu to grace this function. I welcome all heads of the departments, teaching and non-teaching faculty members and students from various institutions. Also, I welcome all the eminent speakers and guests from all over the country from different walks of life who have come here to share their knowledge and vast experience with the student community. Thank you all.
Thank you, sir. Supposing is good, but finding out is better. Imagination is the highest form of research. Now, I invite our principal, Dr. P. Manimaran sir, to address the gathering.
Hello.
Yes, sir. Audible, sir. Sir, voice கேட்கல. Voice கேட்குதா? போய் பாருங்க அவருடைய இதில் சிஸ்டத்தில்.
Thank you. I hope that The innovate முதல்ல சொல்லிடுவா முதல்ல Sorry. Good morning to one and all present here. We welcome you to 8th International Conference on Latest Trends in Science, Engineering and Technology, ICLTSET 2022. As you all might be aware, we have been conducting this conference for the past couple of years, and we have seen tremendous welcome for this conference. We all know the importance of science, engineering and technology. Science is valued by society because the application of scientific knowledge helps to satisfy many basic human needs and improve the living standards. I appreciate the organizing committee for the efforts in bringing eminent persons from various universities and institutions for sharing their research experience. I hope that the innovative ideas, research findings, which will be discussed in this conference, will increase the thirst on new innovations in various research fields. This conference will be an excellent platform for interaction among researchers, scientists, academicians, and students of engineering and sciences. I am sure that this conference will pave ways for further research. I sincerely wish all the delegates, participants, students, and faculty to have a wonderful occasion in making this conference an enabling platform for further expansions in science, engineering, and technology. This conference aims to incorporate and bring out the best in science, engineering, and technology. We welcome all the future researchers to make full use of this conference and all the best to make this conference a grand success. Thank you, one and all.
Thank you, sir. No product is made today. No person moves today. Nothing is collected, analyzed, or communicated without some technology being an integral part of it. Research is creating new knowledge. It is the distance between an idea and its realization. I am profoundly delighted to take an opportunity to introduce the chief guest for the day, Ms. Char Verma, Senior Principal Scientist, Head IT and Digital Information Resources Division, Editor, Journal of Scientific and Industrial Research, Co-PI, Prabhas, Pravasi Bharati Academic and Scientific Sampar, Director, Secretariat and Research Cell, Senior Member in IEEE, Fellow in IETE, Senior Member in CSI, Member in IAENG, Associate Member in TREE-EIF, Executive Member in IWSA. Ma'am did her B in EC from NSIT in 1996. She completed her MBA in Technology Management from IIT Delhi in 2001 and is currently pursuing her PhD in Big Data in e-governance from DTU. Ma'am is a President Gold Medalist in BE, Gold Medalist in MBA in Technology Management from IIT Delhi, EPA Gold Medal from DU, and Lala Jagdishwar Gold Medal from DU. Ma'am started working in 1996 in electronic design automation in Duet Technologies, Noida. Then she joined in Infosys, Pune as software engineer. Then she joined in Infera Information Technologies as team leader. Finally, ma'am is in CSIR NISCA in July 2005 after experience of 9 years in private IT sector. Ma'am has around 26 years of professional experience in IT industry, including MNCs like Infosys. We feel happy to invite you, ma'am. The session is yours, ma'am.
Thank you so much, Veronica. Good morning, everyone. Am I audible?
Yes, ma'am. Audible, ma'am.
Okay. First of all, thank you so much. Thank you so much to the organizers of ICLTSET, International Conference on Latest Trends in Science, Engineering and Technology. And thank you so much to the internal faculty and principal sir of KIT also. It's a privilege to be part of this conference. And I would like to congratulate KIT for organizing this conference. As we all know that, it's very important that we keep pace with the, latest trends in science, engineering, and technology. And that is why maybe these kind of conferences, which are going to be very important motivators and the networking and collaboration for the students and the research fraternity. So as we discussed about this conference, I think the main thing which you would like to consider is the research perspectives in engineering and technology. But to be honest, it may not be very sufficient time to just to go deeper into this. But we will touch upon what exactly are the trends, especially in terms of data science and in particularly big data, and also what exactly or how kind of what kind of projects we generally get into in these research areas. So we'll start with the presentation. And the disclaimer is that more or less I've tried this to be a very pictorial kind of presentation, wherein we have focused more on the content part, what exactly is there in that subject area. And I've taken few things from internet also, and the sources are also been mentioned on the slides. So if we actually go for the emerging trends, they are generally, all know that it's metaverse, it's IoT, it's industry 4.0, and we have AI, quantum computing, ambient computing, and cloud native platforms, and lots of things. You name them in terms of the data science, they're all there. So the common thing about all these trends is that data science may be overlapping part in all of these. Even in case if I go by the prediction by Gartner, they also more or less claim these kind of technologies, which is data fabric, cybersecurity, and the computation or the cloud intensive projects, which are basically generative AI or automobile system, as we are seeing in the unmanned vehicles and the automation in companies like Tesla, and the extensive kind of automation using AI, ML algorithms. These are basically triggering that we need to kind of create more substantial ecosystems in data science in India, so as to enable the data driven or the evidence based studies, which is going to be very relevant for us because we are really very in terms of the kind of population we have, it's very very important that we become data driven. And maybe that is why the mission mode projects like Digital India and other initiatives. So why I chose this topic, the data science, is the current trends are basically going to be facilitated if we are really, really doing well in data science. Maybe that is why that we are taking initiatives at national level for creating the ecosystems for AI or ML or other industry 4.0 initiatives, including cyber physical systems, wherein we have huge kind of investment from government perspective also, so as to facilitate research, and that to collaborative research, so as to bridge the gap between industry and academia. So the agenda is going to be, we all understand what is information age. We know that the data burst is there, and that is why we are calling it as information age. And how the era of fourth paradigm, moving from the first, second, and third one, how big data is going to be facilitating all these initiatives. And what are the 5 V's? And I think we already have one more V, so we have 6 V's in the big data, and we'll go into that. What exactly is that? And why we have data science? What is data science? What are the standards in the data science? And why are they being kind of given to the research fraternity so as to facilitate collaboration, so that we are on the same platform? And then what exactly is data analysis or analytics, and how's that going to be shaped by big data analytics? And then you have, in case we have question and answers or feedback or suggestions, I'll be more than happy to consider them. So I think we all know that data is becoming a key enabler, whether it is data from insurance, data from medical. For example, all your medical records which are kept with central government health agencies or other agencies or different ministries who are trying to keep track of each and every citizen, especially when we want to create some very citizen centric e-governance initiatives. Data is going to be the key, because unless I capture my data, unless I start doing some kind of analysis into the data, I cannot have data driven policies for serving our citizens in a very, very productive and effective way. So we see that data is pervasive, right? Everywhere you have data, even in your mobiles you have extensive amount of data, be it terms of the text messages or the WhatsApp messages, and there's very little segregation between what is productive and what is not. So the catch in the information age is going to be what is the relevant data which is going to be useful for creating further insights and actionable items out of that. So data analytics is becoming pervasive, right? And decision making is becoming more collaborative. Suppose I need to have a solution which is involving data science into cancer detection or maybe the cancer treatment. What is required? I need to get in touch with doctors who are basically into maybe radiation, maybe into some kind of chemotherapy, maybe in some kind of molecular biology, and then somebody who is doing the protein synthesis, somebody who is doing the gene analysis, and then somebody who can kind of model these in terms of computer vision or maybe the AI models. So my decision making is going to be dependent on the kind of collaboration from the different set of people which is going to be there and which is going to make it more effective. But the explosion in data volume is kind of, maybe it's useful also, but it's also creating newer and newer challenges which are going to be the propeller for the latest kind of technologies, maybe the software as well as the hardware. And nowadays there's not much distinction between these because of the kind of smart devices or the IoT devices you have. You also have a layer which is going to have some data into it. So it's very important to sense that data through sensors and all, and also to analyze that. In fact, IoT, everything is going to be the backbone of the industry 4.0. Unless I analyze my data, it's going to be very difficult for me to take some actions which are based on those insights. So the innovative data-driven business models are key and mantra to the success, right? But the iterative decision making process is also very important. Iterative, why I say iterative? Because I may take a decision which is based on maybe a slice of data. Later on, if I just try to collaborate with different set of people, I get more and more data. I may iterate my decision. I may kind of improvise it, right, for more efficacy or more effectiveness, right? Now, so the point is that the leaders who are going to be differentiated into the market, especially in the analytically intense industries, which are basically the health industry, the telecom industry, and automobile industry, banking, oil, gas, you name it, and they are there on the chart. So it's very, very important that I start conceptualizing my data-driven decision support systems right from the inception, because unless I have my scale up plan for these different sectors, it's going to be difficult later on. See, India is now so much, having so much of population. We need to start in a leapfrog manner because we are already a huge population. But these solutions are going to be very, very productive because we know that IT is going to be facilitator in terms of reaching to each and every corner. All our national schemes are very effective since the time we have started automating everything. So we need to reach even to the remotest place. It is going to be beneficial if we create a participative model wherein even the section which is deprived, they are also with us. We are moving in cohesion. So the leaders who are going to be differentiated, they are going to be differentiated in terms of the analytical intensity and also the productivity spread. And I think more or less we all agree that instead of just doing that monotonously through a manual process, if you start automating it, you may be more in terms of spread and also the speed. So this is going to be very, very important. So leaders, of course, who are going to have the significant value which is leveraged from the data analytics, but only the data analytics may not suffice. The kind of data you capture is going to be important. We all know that there were, some decisions on the Brexit movement in Europe, and the decision or the prediction by the system was not correct. And why? Later on, they said that the data captured was not the quality data in terms of the completion and also in terms of the value which it gave to the Brexit decision. So even in case we do data analytics, it's going to be important that how my data was captured and how my data was basically, cleaned and collected. So that is going to be very, very important, right? So these things are very, very important if we do. And also the learners are going to be those who are going to, just gain the perspective from the leaders and start doing some initial investments into the analytics, right? Now, in terms of other players who are onlookers, onlookers are basically those who are yet to invest into the analytics. But nowadays, it's very, very important that we have all these learners and leaders basically trying to guide the onlookers. Of course, the industry may be competitive and it may not happen all the time, but this may be possible, right? Now, data leaders improve the efficiency and effectiveness of the product development. We all know that because the companies like, if we even know, Tesla and other companies, if we start doing data efficiency and effectiveness improvement through analytics, we can definitely have more competitive products in the market. Okay. And these competitive products are going to increase maybe the quality life to the citizens also. And definitely the income level has to be at par with those kind of products. So if we see how we go about this, first step is development, which is definitely the research and the design, wherein we pitch in. The research is going to be the backbone of all these developments. So it's very, very important. And once I have the development, I also need to have some kind of marketing, which is required to be kind of, propagating these kind of solutions. And then, and these kind of solutions are going to be very, very important in terms of the manufacturing and the supply chain. And then, of course, later on, final implementation and also the support part of it. Now, in terms of big data, if I see what is the kind of timelines, I think we started long time back with the printing press and then post and then, the other kind of post, the telephone, radio, PCs, web, when Tim Berners, all these things started with CERN. And then finally, we actually came to a situation where we already have a huge amount of data. And this huge amount of data, we need to come up with the technologies which are going to be very, very important to analyze this set of data. Like we know the things about God particle, the research which is going on for the, these colliders and all that. So you know that data which is generated every second is even more than petabytes, even zeta times at times, which is 10 raised to power 21 bytes. So if I have that huge amount of data, I should have some mechanisms to filter it into what is productive for me and what is not productive for me, and then analyze that data. So my systems are going to be very, very critical, which are not the conventional systems which are going to analyze this kind of data. Okay. Now, if I separate the data from the big data, what is the difference? When do I say that the data is actually my big data? In a very simple, plain language, when I am not able to handle my data through conventional systems, I'll see what are those parameters which differentiate data from the big data. But then it is basically the big data. Okay. The data becomes big data when my traditional systems are not able to handle them. Okay. But what are the relevance of big data? I extract value from it. What is value? For example, I'll give you a very simple retail example, Walmarts and all. Long time back, they were doing some kind of analysis in terms of seeing the pattern of their purchase and the other products. And they saw very good pattern association between beer and the diapers, which was not possible by maybe a naked eye. That's not possible if I just go through my various records in my database. But the kind of algorithm they had, the data mining and the knowledge discovery algorithms, they came to know that kind of association. And then their marketing pattern was basically on these schemes, giving, some kind of discounts on this package. And the reason was those who were new fathers, they were awake throughout the night. And that is why they were consuming the beer. So that was the association. So it is very important to kind of analyze your data so as to help you in maybe making your operations more effective, making, consolidation of your finances, or the other parameters which are going to give you a strategic input for making you more effective and competitive in the market. So, but there are lots of things which come along with the data. For example, the regulatory policy. Generally, the problem is who is the owner? Who's the custodian of the data? That's very, very important. I understand that the perspective may not be important for the researcher, but believe me, those who are the principal investigators for the projects, they have to take care of these points. I remember that we worked for a 12 5-year plan project, which was basically creating a decision support system for all our 38 laboratories of CSIR. I belong to NISPER, which is National Institute of Science Communication and Policy Research, which is one of the labs of CSIR, which is Council of Scientific and Industrial Research. And we have around 38 laboratories across Pan India, all in S&T. So we had to create a decision support system of all our R&D data. Now the point was that how come a single lab can ask for data which may be confidential from different labs? So there has to be some association from my headquarter so as to have the custodian, the central custodian of the data. So these policy things have a very, very strong implication on the success of the project. Okay. And also when the data extends from the traditional database technology, as I said, if my data is being not handled by the conventional system, now what are those conventional systems? We have traditional database technologies like OLTP, which is online, transactional processing. We move on to OLAP, which is online analytical processing, right? And when we moved to multidimensional databases, we started with the relational databases, moved on to multidimensional databases, and now we move to something way beyond that. We come to the parallel processing. We come to things like Hadoop. We use, Scoop and all those things. We use multiple kind of BI tools which are sitting on top of these multidimensional databases. So the important part is policy, the kind of technologies I'm going to use, the kind of systems we are going to use. That is going to be very, very important. Okay. So, but the point is that the big data we collect is still very raw. We'll see that what are the things which are going to make that more cleaner, which is more effective for your prediction. Okay. Now, as I said, there are multiple things which characterize the big data. When do you say that your data is big data? It's not only the size, it's not only the variety. So what are these V's which qualify your data as big data? We have velocity, which we understand, the speed with which your data is generated. As I said, if I generate petabyte or zettabytes of data within seconds of time, then I qualify my data as big data because my conventional system is not able to handle that speed. Then the volume means huge amount of data along with the velocity. Velocity is more, volume is more, it's more, all the more trickier for me to handle that kind of data. And on top of that, if I add variety, which is structured, which is unstructured, semi-structured, like you have all your streams, all your videos, your text from different social media handles and different kind of formats. Suppose in medical world, if I start doing computer vision, it's going to be different kind of scans, my MRIs, X-rays, so many things. These are all unstructured data. And structured, where I can define what is the level. Suppose XML files, you have set pattern of all those tags which are defined in the XML file. That's going to be categorized as structured data. And on top of that, you may have different formats. I may have different XML for simple protocols in medical world, which is called HIPAA, Health Information Protocol Act, or SWIFT, which is in the financial world. So the formats are going to be different. So it's all the more trickier for me. Huge amount of data, different formats, different velocity, and then comes the different parameter, which is veracity. What is that? Which is the credibility of my data, the accuracy of my data, the authenticity of my data. That is basically going to define whether my data is going to give some certain results or not. So it's going to address my uncertainty of data. Then comes the value, and value is basically going to be driven by these 4 parameters. That is the identification or the extraction of the data, right? But as I said, we have more V's now, right? We have variability. These are basically ways in which big data can be used or formatted, right? So one more V is added. Now, in terms of size of big data, if we see that in terms of zettabytes, it's really, really huge. You have all those bits in computer. We talk in bits, in computers. So if you see byte, it's a small amount. Even if you move to megabyte, gigabyte, petabyte, and then zettabyte, which is 10 raised to power 21. So imagine the kind of data which is created, captured, copied, and consumed worldwide. We are not even sure. We're not sure that these data is actually captured in the way that it should be. So this size of big data is going to pose us a challenge, right? And we see that even in our lives, we are so much bothered by the information we generate even on a daily basis. Lots of things in your mobile. So unless you have applications which are going to filter out what is relevant for you, it's going to be really, really tricky and difficult. Okay, but why big data is important? As we said, it's going to be cost reduction. If I give an application to a set of citizens at one go, definitely I'm going to reduce the cost. I'm not going door to door to get that service, to give that service to my citizens, to our citizens. So that is a cost reduction. I can have more and more services and the products which are basically going to empower our citizens in terms of more effective e-governance solutions. So that is why I need big data analytics. And also these applications are going to be very faster and better decision making. I would say effective decision makings, whether it is for CIOs or it is for the policymakers who are going to be there in the government. Okay. So how will big data change our life? Definitely more quality options for your healthier and longer life. Lots of parameters are there apart from just the big data solutions. The kind of lifestyle, the kind of genes you inherit, and also the kind of things you eat. Maybe you're not having the nutritious food. So there are lots of parameters, not just the big data part, but that may help you or facilitate you to have a healthier life, which may definitely trigger maybe living longer. But yeah, you can always kind of have lots of contradiction on this point. But definitely, this is going to be a facilitator, not always, something which can determine in a true capacity. Okay. And definitely you can have, more, effective solutions for your daily grind. As you know that, even if you have Google Map, if you are going from one route to another route, so you can actually have lots of parameters which can drive your route. The route can be dictated in terms of the traffic jams, maybe some car broke in between. So the system is going to give you real time signals in terms of effective and other options available. And also family time. I don't know, with lots of gizmos, are you able to spend more quality time with your family or not? But yeah, these technology parameters or the gadgets are going to give you more quality time. But yeah, if you physically are away and just spending time on these gadgets, that is a different issue. And also the kind of things you can manage through different wallets which are online and all that. And also you can have word like a global village, which is more possible by the connection and collaboration through these applications. Okay, so this is just how we are going to use this data and what are the steps which are involved in this. As I said, even in case you capture your data, you compile your data, you curate your data, the data collection and aggregation is a technical step, and that's going to define dependent on the kind of formats and the kind of structures you have, and similarly the storage and analysis, and definitely which is going to result more into your empowerment. But definitely there are lots of pain areas as well, as you have pros and cons of everything. When you use big data, there are going to be very, 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 very important issues when you deal with different steps. For example, when you deal with data collection, the formats are going to pose you a challenge. You need to understand those formats. You need to kind of, have the ownership, as I said, because it's going to be very important. And some of the data may not be accessible. Maybe you have some privacy issues related to this. The data is confidential. So you need to kind of break all those barriers and come up with a newer ecosystem which has more facilitating policies for you to look into, so as to have more effective solutions which give you the intended part, which is just the empowerment or execution or value or whatever the objective you started with, right? And data storage similarly will have lots of things, maybe hardware also, the software part also. So they're going to be very, very important, right? And also in terms of final solution, the cost to experiment is also very high. I cannot afford to have lots of experimentation with my live systems. So as always rightly said, I need to spend more time in conceptualizing my system so as to have less hurdles later on. So thinking as you write your algorithm or pseudocode is going to be very, very important, as you do while designing or architecting your solutions. You have your schemas or ER diagrams when you design your database. You have UML, you have context diagrams when you design all these things. So it's very, very important that you conceptualize well. As I said, the pain points are going to be there in each and every step. So if you have federation, which is distribution, or no centralization with trying to collaborate with different federated databases, it's going to be very, very tricky. And also you need to innovate so as to have the information burst converted into something which is a value or an action item which is going to dictate your success. Okay. Now governance, as we understand, different departments are going to interact with each other, and each of them will coordinate in terms of data or the action. And now for simple things, for example, if I have a particular service from Government of India, you may not know that there may be multiple departments which are actually involved for giving in that kind of service to the final customer. So these things are going to be important. And also, if I start with my pilot or my prototype, the scaling up is going to be a challenge. And I think this is a very important challenge, because if I see in CSIR from the R&D perspective, we generally create the the technology readiness level, which is 9 or something, and then it is going to be the market which is going to scale up in terms of the production. We will scale up the technology, but the production is going to be dictated by the market. So we know that we deal with this, and this is really very, very tricky and a very important step for the adoption of your technology, which is commercially viable and of value to the market. So this is a very important point. Okay, this is a simple thing. Once you are doing your data analytics really well in terms of taking care of all these steps which I just mentioned, we are going to be the market maker. Okay, and there are lots of verticals which are already doing it. As you can see that the seamless credit card integration between different type of credit cards, Visa, Master, maybe international, OBI, maybe domestic, how it is linked to your NRI account or maybe NRO account, and how you are basically going to track these things. Even our IT department, the income tax department nowadays, is basically using insights. They are actually trying to connect to all those places wherein they fail. They think that they may have some good data so as to avoid the any kind of escapism from the tax paying or another other kind of financial frauds. For example, currently what I know from the public databases is that income tax department is actually trying to collate data along with the credit card data, and later on they may even do with the land records. So you may see, suppose somebody is earning, suppose maybe 1 lakh per month, and you have an asset which is huge amount. You see the land records and you see multiple transaction, and your credit card is maybe not showing that transaction, so maybe you did that in cash, but the land record is giving you some hints that there's some problem with this kind of salary, how this person can have these kind of assets. So this is going to be very, very important data. So this is actually what we saw is what is data, what is big data, how do we differentiate, what are the uses of data, and what big data can give you in terms of leverage about so many things. But why we actually had all these things, because data science is the backbone for all these objectives. If I want to achieve those objectives, I need to understand what is data science. Okay, so I have data. Okay, so what do I do? So is big data same as data science? Maybe not. But big data analytics, which is going to analyze your big data, is data science. But data science is not big data analytics. We'll see what is data science before we appreciate this statement. So data, as we all know, is noun. It's fact. It's basically your raw observation or experimental observation or the statistics which has been collected together, maybe for reference or maybe analysis, maybe for insight, maybe to create some kind of prediction models or forecasting, these kind of things. Science, we all know, it's basically your systematic study, definitely through observation and the experiment. Okay. Now, data science deals with structured as well as the unstructured data, and it is basically associated with cleansing. Very, very important. Like I gave the example of Brexit. If I'm not able to have that kind of data, which is more various in the sense it's more authentic and reliable, I will not have any kind of solutions which were actually anticipated for. Okay. So cleansing, preparation, and analysis of data is very, very important. Data science involves programming with multiple set of languages, be it Python, be it R. There are other languages also wherein people start analyzing data using these languages. Then you have logical reasoning, and these are very basically basic fields which are going to be the backbone of data science field in fact in general. Okay. So also data science will have insights, which is looking from different perspectives. For example, if I have my multidimensional database, a simple query may be a company has maybe 10 products, 20 regions, and different sales representatives and different financial years. So I have 4 dimensions. So the intersection of my dimension is a data point. For example, in 3D, what do I do? The X, Y, Z coordinate is going to tell the position of a point. Similarly, the intersection of all these 4 point dimensions in case of insights is going to give me a data point. This is just a raw data. I need to further that analyze this data. So that is going to be very, very important. So in nutshell, data science is multidisciplinary. Okay, I have multiple things and I have multiple employment options. I can be, a person who is writing models using machine learning. I may be, doing some knowledge discovery using data mining algorithms. I may be doing some database administration. I may be, designing database. I may be doing some visualization using, Tableau and other software from business objects or anything. I may be doing some kind of pattern recognition, which is just doing some kind of analysis of my models. Because you may be writing models, but you may not be equipped with the domain knowledge, which may be required for the pattern recognition. For example, a very simple example is I knew somebody who had brain cancer. And immediately from the MRI, the doctor said, it's cancer. I said, how? Because they know how to read that scan, how to read the pattern of a lesion, which is going to give some kind of bulging into your scan. So these things are going to be domain specific. So that is why you need the domain knowledge. But for solution to be really effective, the business strategy and the analysis and inquisitiveness and the conceptualization, that's going to be very important. And even the stats is going to be very, very important. When I say R, I generally use that for my statistical analysis. Generally, all those techie geeks who would like to do some kind of modeling using machine learning, they generally use Python. Okay, so this is basically to tell you that data science is multidisciplinary. So it'd be really good if you have maybe 2 or 3 of them together. That's going to be very, very effective for you to sail through this industry. And this is going to be the hottest job, and that's a prediction of lots of other companies like IDC and all. So we have umbrella of several techniques for extracting the information, and we have the data products, as I said, which the conventional systems are unable to do it. Okay. And you have lots of areas like data analysis, machine learning, and statistical analysis, and to create a valuable resource, maybe for the business, maybe for the country, maybe for the citizens, maybe for, the other sectors, which may not be, competitive enough to have some kind of competition, but they are more interested in giving some kind of societal benefits to the citizens. So you have a different domain, which is mathematics and statistics, which is along with computer science, and definitely the business domain. So these 3 core things are going to have some intersection, and the complete intersection of 3 circles is going to be the data science. As I said, lots of steps in business culmination of data science life cycle. which starts right from the business understanding, the mining part, the cleansing part, the exploration part, and then of course you select the features and constructs for making it more meaningful, and the predictive modeling, and then we have data visualization. Yeah. Now, in terms of data, in terms of the visualization of how it actually started with the data analysis, the evolution of analytics started with some kind of descriptive analysis. Okay. Descriptive means that I had some information and I start, analyzing that information to see some kind of descriptions in that, which may be, simple. What is the mean of my population? What is the median? What is the variance? How far is my population from a single deviation or maybe double deviation? So these kind of, for example, you have Bell diagrams wherein, these are generally used by universities to see what is the spread of the kind of performance of my students. Okay, so this is descriptive. I take my records in terms of their scores in various courses and then start doing some description. What is diagnostic? I'm trying to troubleshoot. It's like a postmortem. There's something which has happened and I just want to see what is the issue with this one. Okay. And then predictive. Okay, this had happened based on this data. What will happen if I have this kind of data? So that's going to be predictive. And predictive analytics is very, very important when I try to predict. Suppose I say, we want to be trillion economy, we want to be this. Then how do I predict that? I need to have some kind of reverse calculation to see that kind of data, which is going to get me into that arena, right? So that prediction is going to be very important. Prescriptive. I have seen that prediction. Now, what do I prescribe to reach to that level? Nowadays, you have lots of coaching institute. What they do? You want your, son or daughter to be in this area, maybe any profession. It's not necessary engineering or medical, maybe CA or maybe some other profession. It's very important. Somebody prescribes you, but based on diagnostic, descriptive, and then predictive modeling. So the last one is going to be dependent on the previous ones. And the final point is self-learning. With Industry 4.0, what I can do is I can analyze the data from my various sensors and then use the data to create some kind of self-learning for me. Suppose I use Industry 4.0 for my manufacturing industry. What can I do? I can see if my lathe machine is going to break down. And how do I do that? Suppose I'm using a very layman language because I'm not from manufacturing. You may have some kind of heating which is generated by the lathe machine. You may have some parameters which are going to tell you that it's going to break down after some time. So you have already predicted that. You have already prescribed that this is going to be a breakdown, and you have even started analyzing that how will I solve this. You have already learned from that part before it actually happened. So this is going to be very, very important. And then, I'm sorry, my phone is actually, the landline is ringing. So sorry. Data analysis sophistication is going to tell you that how these models actually started coming up in the market and how are they going to be very, very important for the industry to have effective solutions. Okay. And that is how we actually landed up into AI. So this is the brief history. I'm sorry if the slide is not readable, but the catch is that we had merging of multiple set of domains to create a brief history of data science. Okay, to create the domain of data science. Okay, so that is very, very important. Now we see computer science, data technology, visualization, and mathematics and statistics. They are basically merging into data science. So the different areas are giving you different set of information. It's not maybe complete computer science, but yeah, things which are related to database technology, which are related to the different kind of algorithms which may analyze data, that is going to merge into this. And also it's a more compact solution for the data science. But what are the concerns in data science? Very, very important. What kind of visualizations are required? That is generally driven by what your customer or the end user is looking for. And when should I give them? Because those alerts at the right time are very, very important. You know that 9/11 which happened in US, and it was very very surprising for a country like US. This event happened, and I happened to attend one of the workshops where we had people from US, and what they said is that we had some information, all the intelligences had some information that there is some unknown activity over the Pentagon, but they did not collaborate. They did not consolidate and collate that information to come to a single point that if 5 agencies are saying there's something wrong, then definitely there's something wrong. So that alert when is very very important. It may be very crucial in terms of saving people life also. You may have some system, for example, unmanned vehicles in US. If there is any problem in the machine learning model which is there, what will happen? You are risking the life of the people who are traveling by that car. Okay, so that's very very important. Even the few years back you had a plane crash, and what was the issue? The Boeing had a sensor which was not working. So the sensor was thinking as if plane is at a height and I need to kind of reduce that height. But then it was basically very, very important. Yeah. So domain and outcome sensibility, that's also very important, because suppose I'm using in the medical world, it's going to be very, 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 very important that the outcome should be actually accurate. Suppose I'm trying to sense if somebody has cancer or not. If I say yes, and that person does not have cancer, what will happen? You will have chemotherapy on a person who was actually having benign tumors. It was not malignant at all. What will happen? I know of a case where it was by manual prediction, they said that the person has cancer, although the tumor was benign, and that person actually expired within 6 months because chemotherapy was not required at all. So if you start using these systems for predicting something which is life threatening, you need to be very, very sensible. You need to be very, very accurate in terms of your models. Okay. Is data trying to trick us? Yes, at times it may. So you must be knowing that, you should not name that, but yeah, few cartels, the medical cartels, when they come up with new drug, they play around with data, they do some kind of modeling, and they prove that they are statistically significant. Okay. Because the studies like cancer, you cannot have, patients maybe more than maybe 30 or 40. Even in time of COVID, it was very, very difficult to test all our vaccines. So it has to be very, very judiciously done so that the data is not tricking us. Okay. And then, of course, if you are considering multiple set of data, it has to be data right factors have to be considered in these areas. Okay. So these are very, very important. And also the kind of standards you have for the data. Now, there are certain standards also. There is one CRISP-DM, which is basically cross-industry standard for data mining, which also helps you in data science. And this was by European Union in 96 or 97. So these are basically the common steps are more or less same as you have in data science, any kind of, the model implementation, which is business understanding, data preparation, modeling, evaluation, and deployment. Okay. If somebody could tell me if I'm on time and how much time do we need, because I may take 10 to 15 minutes more.
Okay, ma'am. It's okay, ma'am. No problem.
Okay, thank you so much. Yeah. So if we go deeper into this business understanding is nothing. It's like basically analyzing what are your requirements and what is going to be the output for this particular model, which is going to give you some actionable strategy item. Okay. Oh, okay. It's a very similar, simple slide, which I don't want to go deeper into this, that the skills are going to be very important. Those who understand the requirement should actually be the analyst. Okay. You need to ask why, how, why you do this. Okay. Why do you need this? Okay. If you do like this, will be okay. So these kind of things are very, very important. So acumen of the person who is going to do the analysis is going to be very, very important. Now, data understanding. This may be entirely different from somebody who will understand the business. So this is going to be the data analyst, okay? Because this person need to understand where the data will come from, what kind of profiling I need to do that. So, okay. So you need to interrogate the what, why, how, and all those things to understand the profiling and what are going to be the cleansing requirement. For example, I capture the data of multiple set of citizens. At some places I say male, female, M and F. At some places I say MALE or FEMALE. And some places I may say 0 and 1. Some places I may use some other thing. So I need to clean my data and make it consistent. Decide, okay, MF, or whatever you want to, it has to be consistent across multiple set of areas, so that once I collate that into a uniform or centralized database, it has to give me those kind of results which are expected from the model. Okay. And data munging, which is basically collating, blending, analyzing data for early insights. This may be some kind of, I would say, prototyping, which is required initially to understand what kind of data. Because, once you develop any model, I know, as I was in private industry before this, and I happen to be involved in some business analysis and also the data analysis projects, we used to talk to the clients. We used to tell them this is how your system will do that. So you may have some very rudimentary kind of systems wherein you take their data and show them some kind of prototypes, so that they are at least comfortable that going deeper into the system may help me in further analyzing, maybe, or maybe reducing cost for my operations. Okay, so important to be thorough, be corrective, be fast, and also the transparent. These are the quality parameters for that step. Okay. Now the preparation is very, very important. As I said, you may have different formats. So you need to extract the data. You may need to have the transform data, and also finally load that data into a format which is basically going to give that input to your final system. This will include multiple set of tools. The last project we worked on was basically on decision support system, as I told you, that use a BI tool, the business intelligence tool, which was open source software OSS called Pentaho. Now, those kind of tools will have inbuilt extraction, transform, and loading tools. I think it was some kind of, the integration with the multidimensional database. But these are very, very important tools because they are going to dictate the quality of your data. And you may at times need to have aggregation also. What is aggregation? Suppose I say a particular product, my sales for a particular product in UP is this much, maybe in Rajasthan is this much, maybe in Madhya Pradesh this much, maybe in Maharashtra this much, then and multiple states. Then what is my sales from India? So that's aggregation. I summarize my data and drill down. Maybe I go deeper. From India I go to multiple states. Okay. And pivot, I think you understand from the different dimensions, how do I analyze my data. And definitely data preparation, because you involve database, you have multiple things which are possible. You may have Spark, it also has a data frame, and there are multiple options like streaming and MLDB and graph and all those things which are there. Okay. Now data science quality priorities, speed to value. If I try to just make my systems more faster, my data is going to be posing some challenges. Okay. So I need to balance out into this. As you know, I generally, what I do, I find break-even points so as to decide what is the selling price of my product. Similarly, it's going to be very, very important to come at a balance wherein I have a speed to value balance along with the data quality. Now, in terms of modeling, I think when we come into data science, it's going to be very, very important that we understand what is machine learning, what are different machine learning models in terms of classifications, clustering, regression. I'll just touch upon them so that we know what are these. And once I have models, how do I tune my parameters to have the highest possible accuracy? But as I said, there may be some kind of pros and cons. When I try to increase my speed, I may lose some quality of my data. So what is important, as you must have already knowing that in statistical analysis, you have type 1 and type 2 errors, right? So you balance into that. What is more important? I can, just live with type 1 error, or I can live with type 2 error, which is definitely you try to optimize both of them, but which one can be larger as compared to the other one? And also you have iterative processes, because those who program in machine learning and AI, they would know that I have lots of iterations and simulations which give me some kind of features for the data which I try to analyze, and I see what is the accuracy of my models. Okay. So different models may require different kind of data. You may have different techniques like sparse vector formats and all those things which are required for that kind of analysis. So this is very, very important. As I said, we have been using Hadoop to model this data also. And R and Python are very, very important for these things. As I said, machine learning in a very layman language is that I'm giving huge amount of data to my machine to understand the patterns and the associations which are there in my data, or what are the features, characteristics in my data. And then once my machine has learned that process, I give a new set of data, and my machine, based on the learning it has done, can make decisions or the predictions which it has been programmed to do so. Now, if I broadly take machine learning algorithms, I have two set: supervised learning. That means a small child has been, dictated by his or maybe her mother or father to maybe, just take few steps, or even the mother is actually holding your hand to make you walk. So that's kind of supervised learning, right? Somebody is trying to kind of facilitate that part for you. Unsupervised, you have been taught how to walk, you actually did lots of things with your walker, now you can walk on your own. So you're finding patterns or within data, but now no training data is supplied, so you can do on your own. We will review some popular easy to understand machine learning algorithm. There are basically many, so I think we just see that this is, but once I go into supervised learning, I have classification. Suppose simple classification, maybe I give multiple set of features. Is it a dog? Is it a cat? Or is it an orange or an apple? Of course, for different algorithm, of course, that's different. Then regression. I create a model, suppose to predict the inflation index of India. So I created a regression model, okay? And then unsupervised. And believe me, for data science, it's very, very, I would not say essential, but it's very good if you know these statistical concepts also. What are parameters? What are parameterized functions, non-parameterized functions? What are discrete variables? What are continuous variables? That will help you that what kind of models and the techniques you can actually use to analyze your data or to create more effective models. Okay. As I said, when to use what. So it's going to be important when to use classification, when to use clustering or regression or dimensionality reduction. Dimensional reduction is basically like principal component analysis, like you generally do when you do your statistical analysis in your PhD. Suppose you use that SEM. You try to reduce your data into as small number of dimensions as possible, and also all those dimensions should be mutually exclusive. They are not overlapping with each other. Classification, as I said, clustering, maybe you have different set of students. These are above average, these are below average. I mean, the categorization is not to demean anyone, but the categorization is to come up to some kind of effective plan so that my below average students can also be at par with the above average students. And regression, as I said, for the modeling. Categories and values, these are basically used for the classification algorithms. And this is a subtle difference between regression. I'm doing a prediction based on, I try to fit in my data into a single line model and then use that model for my prediction. But for classification, I may be having a, dividing line between two type of, or depends on how many types of classifiers I create, okay, or different categories I create. Decision trees, nothing. I suppose you must be, aware of the bubble sort algorithms or the balance trees algorithms where you try to sort the numbers. So suppose I try to, create a list, a decision tree wherein, the left side is maybe numbers which are less than 65, the right side number which are greater than 65. And then I try to create a node and insert that node. So first what I do, I check whether this is left side or the right side, whether the number is less than 65 or it's greater than 65. So that is how I create my decision tree based on the multiple set of features or the characteristics of that particular data. Okay. So this is just very simple example of decision trees. And the other step is evaluation of my model. Once I've created my solution, I need to evaluate against that whatever my original objective which I started with. Does it meet my objectives and does it address all my issues? And then finally, the deployment. If the answer to them is yes, then definitely the deployment is going to be there. And I use my predictive model markup languages also, which is again XML based interchange format to deploy my solution. And then I decide technologies. I may host my solution on cloud, and cloud also I have multiple models, multiple options. And also I saw that, I can use multiple modeling techniques and also the data preparation techniques. So these are just the techniques in different phases of your CRISP-DM model. Okay. So this is too late, but yeah, we know that analysis is different from analytics. Yeah, more or less, I think everybody would understand this or maybe knowing this. Analysis is basically dealing with the analyzing past data and understanding the data. Analytics is basically using these insights to make some business decisions, which may definitely be smarter in terms of efficacy and the efficiency. So this is just the innovation system of data analytics in terms of, as I said, you need to prepare your data, you need to have then storage, then you have ETL tools, also the visualization tools, which are basically coming from the presentation layer. Okay. And in terms of architects, we can have definitely architectures in terms of this. We can have relational databases, you have multiple SQL based things, then you have multiple other tools which are NoSQL or multi-dimensional databases, and then you have ODBC, which is open database connectivity, which provides you kind of you're not sticking to a particular set of you're not basically hard coding your code, right? So that is open database connectivity. This we more or less understand how we actually traverse to multiple databases. The efficiency issues which are there while designing your solution is indexing, your disk management. How many concurrent users do you really have? Those who really, just design these systems, the IT systems, they understand that concurrent number of users is a parameter which basically dictates what is going to be the kind of scaling I require for my system and how the load is going to be balanced, and also the query optimization. Query optimization, definitely, there are certain concepts which are from their DML, which is data manipulation and definition, and data control languages using joins and all. And the other issues may be how do we scale up and what kind of data warehouse if I need that. For example, the stock exchange, all the records of the transactions throughout the day, they are actually stored in OLTP. And at the end of the day, or maybe frequency, depending on whatever is their requirement, they slice the data into their data warehouses. Now, slicing can be on multiple dimensions. Dimension as in the multiple MDD, which is multi-dimensional databases. The dimensions are slightly different, which are used for data warehousing designing. So these are also different. Why I'm touching upon these points is you may have these kind of systems which are already there and you may be generating big data out of them. So how do you actually take data from them? So that's going to be important. The unstructured data is definitely a huge challenge for your data science, because you may not be knowing what is the format of the data. You have not seen it before. So you're going to see how do you analyze this data so as to create a database which is quite realistically real-time similar to this unstructured data, streams or images or videos or XML files. XML files may be somewhere between structure and structure, because XML files still can be traversed by XLT processors. So you can do that. As I said, for that example of a company where you have multiple products in multiple regions, so this is a kind of rubric which shows you a multi-dimensional database, which is basically the aggregation of multiple dimensions to give you a data point, and which is generally used in OLAP servers for creating your federated or centralized data warehouses. Data integrity is going to be very important to tell you missing values, duplicate values. How do you fill those missing values? That's going to be important. What are the outliers? Suppose a student scoring 60 marks out of 100. There's one student scored 95. There's only one student out of 100 students. So there are just one outlier. So do you want to keep in the analysis, or do you want to remove that so that you have realistic analysis for all the students? So that's going to be very, very important. And then again, the interoperability of this comparison, difference, records, mapping, standards. Do I have centralized or federated database? That's going to be the challenge while designing the interoperability part of this. Data cleansing. As I said, if you are missing data, how do you fill it? How do you remove the outliers? How do you smoothen this? How do you remove that noise? Do you average it out? If you average it out, what are the values which you need to consider during the average part? And then filtering, sampling, this is going to be important. And also numerical data. As I said, you need to understand whether you have numerical data, you have alphanumeric data. Is it discrete or is it continuous? My parameters are going to be, my algorithms are going to be entirely different based on the kind of data I have. Data mining, I think it's more or less okay. We understand it's going to be knowledge discovery, and the statistical techniques. These are basically the techniques which are going for your AI, the analysis for clustering regression and other analysis, scoring and neural nets. So machine learning and data science, we understand now. Machine learning means the algorithm is something which depends on data, which is used as training set to first learn the machine, and then later on the machine is going to predict you for that. And the subtle difference between data mining, we understand that it may apparently be very similar to machine learning because of the kind of things it also does, because it does association and also the pattern identification. But here the algorithms are basically, unlike machine, the algorithms are only the part of the data mining. But in machine learning, what you have, you also focus on data because you're gaining knowledge from the data. BI is also part of some kind of analysis or giving you intelligence and all that. But it's basically the retrospective, I said. It's kind of postmortem. It may not be as predictive and prescriptive as data sciences. Okay. That can give you more actionable decisions. So that's it from my side. So I'm happy to take any question if that is feasible or any suggestion or feedback. And it was really, really nice, interacting with you all and giving this opportunity. So I once again thank all the organizers and also the principal and the faculty of KIT for giving this opportunity. Thank you so much.
Thank you, ma'am. We appreciate your interest in the field of science, research, and all the knowledge about data science and big data analytics. Your ideas and suggestions have provided us a guidelines to proceed more precisely for the betterment. Once again, thank you, ma'am.
Thank you so
Everything
much.
is
Theoretically impossible until it is done. Always believe you can do it. Now I invite Dr. S. Gopinath sir, Professor and Head of Electronics and Communication Engineering Department, to deliver the vote of thanks.
A very good morning to one and all present. It is my privilege to get an opportunity to propose a vote of thanks on this occasion. I am very much thankful to all the participants for coming to KIT to attend the conference. I am sure that the ICLTSET 2022 will continue to get generous support from various organizations in the future. I am very much thankful to our chairman, Dr. R. Vasanthakumar, Karpagam Educational Institution, whose strong spirit to uphold the higher academic standard has led to organize this highly purposeful event. Thank you, sir. I sincerely thank our today's chief guest, Ms. Charu Verma, Senior Principal Scientist, Head IT and Digital Information Resource Division, Editor, Journal of Scientific and Industrial Research, Director, Secretariat and Research Cell, OPI Prabhas, CSIR, New Delhi, for kindly accepting our invitation and gracing the inaugural function. We are greatly encouraged by your gracious presence and immensely benefited by your inspiring address and valuable address on data science. On behalf of KIT, I express our deep gratitude to you, ma'am. Thank you, ma'am.
Thank you, sir.
I thank our beloved principal, Dr. P. Manimaran, sir, for his inspiring mentorship towards the success of the conference. Thank you, sir. I thank our beloved Vice Principal, ma'am, Dr. T. Bono, for her continuous support and advice, which have greatly helped us towards the successful organization of ICLTSET 2022. I am also thankful to our management in general for providing us with valuable logistic support towards organizing this event. I take this opportunity to thank all the reviewers and technical committee members for providing their valuable comments in time and help towards the improvement of quality of papers presented in the conference. I acknowledge the unwavering support received from all heads of the department and faculty coordinators. I hope this conference will provide a platform to share knowledge and expertise and critical review of these issues leading to the defined goal of our profession. Now, the most important, My special and hearty thanks to conference coordinator, student volunteers for the support, dedication, teamwork, and untiring efforts. I once again thank everyone whose contribution has made this conference a successful one. Thank you all. Thank you, ma'am.
Thank you so much.
Thank you. We can leave. Ma'am, we can leave the studio.